The Assuring Autonomy International Programme and the MSc in Safety Critical Systems Engineering at the University of York have collaborated to produce a course on the safety assurance of robotics and autonomous systems for industrial safety practitioners, regulators and systems engineers engaged in robotics and autonomous systems projects. This course is based on the research and guidance being produced by the Assuring Autonomy International Programme. The courses can also be taken as a 10-credit module as part of the Safety Critical Systems Engineers Master's Programme at York. Here we introduce the nature and content of this course. Robotics and autonomous systems such as autonomous vehicles, care robots, industrial cobots and autonomous ships are currently being developed to avoid boring and repetitive jobs, increase capability and in some cases improve safety. Whatever the intent, hazard identification and mitigation, a safety case and associated safety management processes need to be developed to ensure and assure the safety properties of the proposed system. Challenges and mechanisms for addressing these activities are the subject of the course. The course assumes that your organisation is currently undertaking an appropriate and recognised systems engineering and system safety engineering process for safety critical systems that have a significant software element. These processes will address four main elements. First, what a good outcome with respect to safety looks like is known for the system, given its operational and use profile. Second, a process that defines and decomposes system requirements through a formalised development process exists and is followed. Thirdly, a process that identifies safety requirements and decomposes them as development progresses exists and is followed. Finally, a safety assessment or safety cases produced to support the release to service of the systems. These four elements have been colour-coded red, blue, yellow and green. Robotics and autonomous systems, especially those that employ machine learning, challenge our current practices against all four of these elements of system safety engineering. This course explores these challenges but also starts to provide guidance on their solution. Further, it points to the latest research that explores these aspects further. Here we have identified illustrative issues relating to the assurance of the autonomy aspect of a system during development. We define autonomy to be the ability of a system to make decisions independently of human control actions. Challenges include the production assurance of a safe operating concept for the RAS. To make good decisions, the system must know its health status in terms of the capability of its equipment, such as sensors. It must also be aware of the operating environment around it. This course explores the activities that should be undertaken with respect to autonomy in the safety process and the resulting evidence that can be used as part of a safety case for the autonomous system. We call this the SARCE process. Similarly, there are issues relating to the use of machine learning components. Here we show that the way that machine learning components are developed are different from the way that software has historically been created. The workflow incorporates data collection and management, model learning, incorporation of the model into systems and software, and updating the component as required. The course will address the assurance of the contribution of machine learning components to safety. The guidance on how to assure machine learning is called AMLAS. AMLAS is the most mature guidance available on activities to undertake and the resulting safety assurance case that can be made relating to the use of machine learning components. AMLAS has 5 elements and must be visited on multiple occasions through a systems development lifecycle. The course provides you with some initial background information via material presented on our virtual learning environment. We then convene at York for 3 days. In York, experts from the Assuring Autonomy programme will introduce the elements of machine learning from a safety practitioner's point of view. They will then discuss the latest research and emerging guidance in what safe looks like for robotics and autonomous systems, the ethics associated with RAS, the latest guidance relating to the assurance of autonomy and machine learning components. The SARC and AMLA guidance will be investigated in depth. After the York Week, we'll give you pointers to more lectures and research material to read to consolidate your learning. We look forward to seeing you on our course to discuss the latest thinking on robotics and autonomous system safety and safety assurance. If you would like to book a place on this course, please go to the website identified here and fill in the form. I look forward to seeing you at York for our course.